So here we go. All right. And I think we'll just do like 2, okay? Or like I'll do one, and then you can do one. Do you need a napkin or something there?
Yeah, napkin.
All right, I got you.
Explosive. I was not expecting it to be pressurized.
Gotcha. Well, all sodas are somewhat pressurized, but I see it was like shook up,
Yep.
shaken, not stirred. All right. So first of all, let me just get this up, and then I'll help you out.
You didn't spill too much, and besides, this is diet. There's no sugar in it.
Oh, that's good. So it won't be sticky.
No.
Okay.
Well,
I didn't realize that was a property of diet drinks that, like, if you spilled them, they wouldn't be sticky until, like, just like a year or 2 ago. Yeah.
well,
It's because when you do like those Mentos, things or whatever, if you use the diet soda, then when it shoots everywhere, it won't make a sticky mess. It'll just make a mess. So, all right.
let me get you out. Well, technically there is a vanishingly small amount of actual sugar in there, but it's not very much.
Yeah. I got you. Napkins. Here we go. I'll give you a couple here. Ooh, they're fancy napkins with big scallops and clamshells and stuff like that. Don't forget, by the way, we got some more food in here. We're in 3rd place. So, by the way, if we win, we get a free breakfast, I think.
Really?
Donut breakfast or something?
Donut
Yes.
breakfast.
So, why not bring some food in? Help us win that breakfast. So canned food right there, right? Okay, yes, bro.
Is it like Thanksgiving food or regular food?
Yeah.
Thanksgiving
fine.
food or regular food?
So if it's a lot, we can get you like a cart or something like that and bring it out to like your car or something. You let me know what day you're gonna bring it. I can help you with that. Okay. This coming Monday? Well, if you want to come back before the bell, before 7:20, come and get me. We can go get a cart, get it, and then bring it in and do that. That's fine. Just make sure it's not expired, right? No expired food though.
Is this one of those like Thanksgiving for 4 people type of things, or is it just?
So it's like because people are hungry all year round, not just Thanksgiving, but so it's like it's for the food bank. So yes,
So
essentially.
any
Any canned food, yes. Anything. So I have a list over here. So for example, good things would be canned tuna sandwich in peanut butter as well, or beans, pasta and rice, again in like a box or something like that. Canned vegetables, ideally low sodium or no salt added style. Fruits and juices, I guess, but again in like light syrup for the fruit or in its own juice. Fruit cocktails, those kind of things. Applesauce and juice boxes are good too. And then breakfast cereals, oatmeals, quick oats, granola and cereal bars. Those kind of things.
There's actually a severe lack of cereals in food banks.
Oh, okay. Well,
Which is really sad because a lot of the
cereal's delicious.
food banks have kids.
Yeah,
And
right. They like
they
the.
don't have like typical cereals.
Yeah.
They really are conventional, like I don't know, tuna, I guess.
Yeah, right. Exactly. So yes. Please bring stuff in.
You know that they have food banks for pets. I volunteered.
Bless you. I did not know that.
So like if you like they also offer like free veterinary care. It's just like part of the ASPCA.
It's nice.
One cat came in and asking one guy and his cat came in asking for Prozac. Cat Prozac.
They do have that kind of stuff. I
They
think.
do.
I'm also passing the homework sheet around. Okay. Homework sheet's coming around. Make sure you fill that out, and then let's get into this one right here. Okay. So like I said, I'm going to do one. I'm going to have you guys do one, and then I'll get you started on the assignment because I think we're doing pretty all right on these. Remember the things I'm going to ask you to find. Find the zeros. Find the middle behavior, what I'm going to call it, right? Which is really just, what's happening between the zeros. Do we go up and then down? Do we go down and then up between the zeros? That kind of thing. Okay, and of course we want to identify that end behavior. Okay, which is what we did for the warm-up. And then put it all together for a sketch. Okay, you're more than welcome to find more points if you feel like you really need to. Again, you just pick any x value, plug it in, get the matching y value. But this is kind of like a good, efficient way, I would say, to get this stuff done. So anyway, to find the zeros, what do we do here? How do you find the zeros of something like this? Set it equal to 0, exactly right. So 0 equals x minus 2 times x plus 4 squared times 2 minus x. Okay? And then, sorry, Aiden?
When there's a 2, the same 0, doesn't that mean that it bounces off the x-axis or something?
Yes, yes. And really, it's for any, like, even-powered, like, root or whatever. So if you had a 2 or a 4 or a 6, yeah, exactly right. And so again, you can use it to help guide you if you want to. I'd still like you to get the middle points there, but yeah, you can use it to help guide you and stuff like that. And you're exactly right. Yes, like a double root or a quadruple root. Bounces on it. All right. So our zeros here in this case, 2, and we'll see that show up here in just a second. -4 and, 2 again. So actually they're both double roots, aren't they? X minus 2 and 2 minus x. Yes. But you can list it twice if you want to. You don't have to. This one I just happened to list the 2's twice, but I didn't list the -4 twice. But yeah, you don't have to list it twice. Just once is fine, I would say, for the zeros. Okay? All right, then we will go to the middle behavior here. I'm going to put these again in numeric order. I really suggest you take those zeros, put them in order, so you can more easily see what your intervals are here.
-1.
So, right, we can use -1. That would be a good one. It is, and I like to use the ones that are halfway between there. Okay, but you can also use 0, because 0 would be easy to calculate with in here, but -1's not that bad either. So let's use -1. All right, so we're going to plug -1 in. So I'm going to use my little, symbol here, y evaluated at x equals -1. And that's going to be here, let's see here, -1 minus 2 will be -3. -1 plus 4 is 3. Squared will be 9. And then 2 minus -1 will be a positive 3. Like that. Okay. So -81. So when we get there, so we get the point -1 comma -81. Okay. And so we have one more thing to do. End behavior, right? Let's do that.
Could you do that again? Sorry.
Yes, 1 sec. All right, you weren't here yesterday, so that makes it trickier here. So all I did was we are taking our zeros, okay, and we're finding the middle behavior. So that is what's happening between the zeros, okay? Because we know that since our zero is going to be on the x-axis, so either we'll go up and then back down to the 0, or we'll go down and then back up, right? So which one is it? So we pick a number between here. Okay, and Rose suggested -1. I would use that one too, probably, because I like to pick the one that's like exactly halfway. But you can use any number in here. Okay. Then you so this little symbol that we learned about yesterday, it means y evaluated at x equals -1. So it's like you're taking y, which is what we've got right here. We're going to plug in -1 for x at each one of those things, and then I just kind of did that arithmetic in my head. So -1 minus 2, -3. -1 plus 4 is 3. Squared would be 9, and then 2 minus -1, positive. And then you just multiply those two together to get your final answer there.
Okay.
Make sense? Okay. So, last but not least, end behavior. Okay. So, Natalie, what's going to be the degree for this polynomial here? 4. Okay. Yeah, you're right. It is going to be 4. Degree is 4. Okay, so that's even. And again, we can tell because this x here is going to multiply with this x here, but this x is really an x squared because it's being squared there. So it's going to be x squared, and that's going to be then an x as well. So x times x squared times x will be x to the 4th. And then what's the lead coefficient going to be here now? Negative. Yeah, so we have a positive here. X squared will still be positive, then you have a -1 there, so it'll be positive, positive, negative. The lead coefficient is going to be negative. Okay, so negative lead coefficient. Oops. Okay, just like that. So with that in mind, then we can now see. Okay, we can now see what our end behavior is going to be. So as x approaches infinity, f of x is going to approach something, and as x approaches negative infinity, f of x will also approach something as well here. Okay, so now can you help us out with that part 2 then? As x approaches infinity, f of x is going to approach what? Negative infinity. And as x approaches negative infinity, f of x will approach negative infinity as well. That's right. Okay. Question.
On the test to like receive all the points, like are we required to write out the end behavior, or do we just show it in the graph?
I think on the test it's going to be like given to you as like blanks to fill in potentially. Okay. I don't think I make you like write out the whole thing.
So like we'll still have to write it.
I'd like you to again, yes. Just again for now. After this point, because that's what we're learning it now, and after this point, if we ever have to do it, you know, you can kind of just like do what you need to do. But just for now, just to have it written out and stuff. So that's all. All right, questions up to this point? Okay, so now let's go ahead and then graph this. Okay, so again, I'm trying to like kind of take it all in here as I plan to graph this. So taking it all in, my zeros are pretty, small. I need to include -4 on my x-axis and 2. So I need to go from -4 to 2 at least on my x-axis. My y-axis, I really only have 1 point, and it's at -1, -81. It's pretty low. So I'm probably going to need to count by something else on my y-axis there. Jeff, I'll be with you 1 second. Let me just finish with this thought here. So I don't really need to consider anything above my x-axis, though. So I'm probably going to graph my coordinates something like this. Okay, so I'll graph that, and then I'll put the x-axis like up here. Okay. To give, again, what I need that kind of lower part of the graph for the -81 that I'm going to be graphing. Okay, and we'll just plot some points. So 1, 2, I don't go up to 3, I don't need to, but and then -1, you get the idea, 2, 3, 4. Okay, and then, yeah, Jeff, sorry, go ahead.
I think I kind of understand this, but how do you, one thing that I'm confused on is, how do you find the relative minimums and relative maximums?
So, well, we don't find them exactly, okay? They do show up, though, in this like kind of middle behavior, right? In between the zeros is where they're going to happen, right? And so we just pick, I just have you guys pick a number between the zeros.
Oh, okay.
And then we just kind of use that to kind of like estimate where it's going to be.
Okay.
We won't be able to find it exactly without calculus or our calculators.
Okay.
Okay, it's not precise, but it gives us a good sketch at least.
So basically just go as close to the middle between the 2 zeros as possible?
I like to pick the midpoint, but you really don't have to, okay, because it doesn't have to happen at the midpoint where the relative min and max occurs. So, all right, let's plot this thing. So we have a 0 at 2 and a 0 at -4. Oops, I forgot to do my y-axis here. I'm going to count by, I don't know, let's do 5. So 5, 10, 15, 20, 25, 30, 35, 40. Whoa. I should not have counted by 5s. Yeah, I'm going to count by 10s. Let's do that instead. Or you can count by 20s. That'd be good too. Gets there faster. So now I really 10, 20, 30, 40, 50, 60, 70, 80. Okay, good. So there's -80 right there. Yeah, we'll just do that because I did not leave myself enough space to count by 5s. Okay. We have another point then, the -1, -81. So there's -1. -81 then is like right here. Okay. So we plotted our zeros. We plotted our middle behavior, only 1 point, because there's only one real interval there. Okay. And then we'll do our end behavior, right? So again, as x approaches infinity, that is, as we go further and further to the right, I'm going to go to my rightmost point here. We're going to go down. So from here, we're going to go down. Okay? And then as I go further left, I'm going to go to my leftmost point. That's approaching negative infinity, right? We go to the left. And we're going to go also down from here as well. Okay? Now, we're going to connect the dots. So I have to go from my 0 here to this point. So I have to go down from my 0 to get to this middle behavior point. And then I got to go back up to get to the other 0. Okay? And then go back down again. So you can see here, we kind of have this like completely negative graph almost there. Okay. So it looks like that. It like bounces down as Adrian described earlier. We have those double roots. -4 is a double root. So you see that bounce right there. And 2, it turns out to be a double root as well. So you get a bounce right there as well. Okay. Questions on any of that? Anyone else think fill in their grade looks Okay. Cool. All right, let's have you guys try one. See how we do, and then we'll get you started on the assignment. Okay, so here we go.
I already did it.
You already did it.
Oh, I put it in the wrong spot.
Huh? All right, so there's one for you right there. Okay. Thank you, guys. All right. Okay. So again, find the zeros, find the middle behavior, find the end behavior, and then graph. And I will do the same. All right. Question? Walk through it? Sure. Okay. So, yeah.
Is that x? What is that?
X to the fourth plus 5x cubed minus 6x squared.
X to the fourth
So,
plus
find the
5x
zeros. So, how do you find the
cubed.
zero? Yep. And in this case, it's not factored. So you're I'd say take out GC. Yep. And I'll look at my paper too real quick while you're doing that. And then you'll have a quadratic, which you can also call a factor, right? And don't forget 0 as well, because the x squared you had up front. You'll also want to set this equal to 0 too. So then we're going to determine what happens between those zeros. Okay, there's probably some similarities, but yeah. Okay, so all I ask you to do for this is to put the zeros kind of like, I put them in numeric order, and I ask you to pick a number in each of those intervals. So pick a number between -6 and 0, pick a number between 0 and 1. So like between -6 and 0, what's your number between those two? Yeah, and I like that one too because it's it's halfway. There you go, right? And then what else between 0 and 1? Yeah, we'll probably use a fraction of 1 half. Okay, and then you're just going to plug those into the function to get their matching y coordinates. Well, you can plug it into either version, either the original one or the factor version. It's the same thing, right? So you can plug it in here, there, plug it into here. You plug it in here, just don't forget there's an x squared in front there. But
I got two of the zeros by pulling out the x squared and setting each of these factors equal to 0. But there shouldn't there be 4? Where are the other two? Is 0 one of them? Okay. Fair enough.
no, I think it's right. Yeah, negative 108. Yes, that's right. Small. And so then the end behavior, hang on, let me just come back. I just want to check something real quick here. Okay, yeah. And then the end behavior is determined by the degree of the polynomial and the lead coefficient. Right, so this is what we talked about yesterday. So, I mean, I'll brief you on it today some, and then if you all want to, check out the video and stuff like that, it's on the Google Classroom, that'll also help you out some. But basically, there's kind of like four different ways you could have end behavior. Either they both go up at the ends, they both go down at the ends. One goes up as you go to the right, one goes down, or the other way, kind of thing like that. All right, it's like a little teapot or whatever. So, in a scenario where you have an even degree, so even degrees, but the end behavior is the same on both ends. Either both go up or both go down. Okay. And so how do you determine whether it goes up or down? Well, it's the lead coefficient. If your lead coefficient is positive, you're going to go up. If your lead coefficient is negative, you're going to go down. Yes. So in that case, it's positive one, so they'll both go up in this case.
Figure out the arithmetic to plug a half in here.
Because you have a positive one, your lead coefficient. That's a
Try
3
breaking
or 4.
it down.
Say again.
So do like
One is the lead coefficient, it's positive. It's the degree, which is the
so I
highest
did 0.5
power.
times 5,
Right?
and I heard
That's
what
the
that was.
difference.
And I did 0.5 minus 1, but then here.
0.5. So that's 0.25.
Yeah. There's, and then don't use the equation that you did after.
Okay. So 0.25 times 0.25 plus.
What's your scale?
They use this one.
Oh, yeah?
You like just use the one that
So point.
so 0.25.
And I might have like cut out some of
and
that,
then 0.25.
that you guys did.
Oh,
Some extra stuff,
your
that
equation's
you-
wrong.
It is.
But so yeah, so you have once you have those components, then you're gonna just come up with your coordinate plane here, plot your zeros. So there's let me get my other plane here. And of course, you want to create your scale fit what you're gonna have. The zeros here are not crazy, so we can just kind of keep it a scale of 1. But then since you have that like really low point, you're kind of like 10
digit in this
down
equation.
here. So we have one at positive 1, one
It's supposed to
at 0,
multiply
and one at negative 6.
to make this one and add to this one, and you get the opposite.
And then at negative 3, we had negative 108.
So
It's negative, yeah, it's x minus 1 and x plus 6. That multiplies to
Yep.
6.
And then 1 half is 18.
Yeah, and then plug
so that's
0.5 in each of them.
Yep, and then the end behavior, I like to kind of show that,
Negative
start with
6,
that, or like end with that, I guess I'll say. So like, as x approaches infinity, I go to the furthest right point, and I know I need to go up from there. And as x
Still
approaches
a
negative
half.
infinity, I go to the furthest left point, and I know I need to go up from there. And then you just connect the dots.
but I can use negative 1 if it's that.
It's like this and goes way down.
So
and
You can
then
use negative 1.
Yeah.
And
Yep. Except for
good?
mine's really
Negative
Okay.
1.
Yeah.
And hopefully, like I said, I'm trying to get you some time to work on it here in class. All right, folks. Not the button. That's the button. Okay, there we go. So there is what it looks like. Something like that. Freeze. Okay, so the little twist here is that you had to factor it. Okay, it wasn't already factored for you, but we could use our tools that we have at our disposal, right? GCF, and then factor the quadratic that's left over. You get 3 zeros: 0, -6, and 1. Don't forget, when you factor that x squared out, right, that's going to give you a 0. Okay, so don't just like forget about it, right? It's one of the zeros. In fact, it's a double root there. Okay, so 0, -6, and 1. Then between our zeros, I chose to use -3 and then 1/2. -3 gives me the very small -108 there, and then 1/2 gives me -13/16. Ugh, that's kind of a weird combination of really far away and then really close. So, but anyway, there are the zeros. Okay, there's -3, -108. There's like the 1/2 comma -13/16. End behavior is both goes to positive infinity. Okay, so we go through with the -6, we bounce the 0, and we go through with the 1 there. there's your graph. Okay, again, estimate, sketched. Questions on any of that? All right, so your homework is on Google Classroom. It's out of the book. Okay, I will simultaneously post the test review if you prefer to work on that. That's your choice. But we will have a day devoted to the review on Monday as well.